Hello everyone, how are you? Welcome to another question and answer session. This is the physiology portion of the MRCS. Which of the following condition is most likely to be associated with the following arterial blood gas analysis? First of all, pH, which is 7.48, partial pressure of oxygen 10.1, bicarbonate 30, partial pressure of carbon dioxide 4.5, and chloride ion it is 96 milli equivalent. So what may the cause? At the options are respiratory alkalosis, metabolic acidosis with normal anion gap, metabolic alkalosis, metabolic acidosis with increased anion gap, and type 2 respiratory failure. So first of all, let's see some important parameter which is very essential to calculate or solve any type of the ABG report. First of all, the pH is normally 7.35 to 7.45. Partial pressure of carbon dioxide it is 4.5 to 6 kilopascal. Standard bicarbonate level it is 22 to 28. So it is a normal arterial blood gas analysis report. The normal parameter. So most important pH which is 7.35 to 7.45, partial pressure of carbon dioxide 4.5 to 6, partial pressure of oxygen it is 11 to 14, standard bicarbonate level it is 22 to 28, and anion gap 10 to 16, chloride 98 to 107. So this parameter you have to remember very carefully because these are very important to solve the ABG report. So let's see here the metabolic acidosis and metabolic alkalosis. In case of metabolic acidosis, so what occurs when the pH reduce, then bicarbonate and carbon dioxide both reduce. But here important point that the bicarbonate level it represent the metabolic part. So when a pH changes occurs due to metabolic acidosis, actually it affects first the bicarbonate level, and when compensation occur, then partial pressure of carbon dioxide response and it also reduce. So in case of metabolic cause, when pH reduce, all the parameter reduce, and in case of metabolic alkalosis, when pH increase, all the parameter increase. But the first response is the bicarbonate, because the bicarbonate level it represent the metabolic cause. So the bicarbonate level as it represent the metabolic cause. So when metabolic, first of all we have to look for bicarbonate level. Then go for the respiratory acidosis. In respiratory acidosis, the pH reduce. As pH reduce, partial pressure of carbon dioxide increase and bicarbonate increase. But in case of lungs, there is primary parameter is the partial pressure of carbon dioxide. So when their partial pressure of carbon dioxide increase, and then during compensation bicarbonate also increase. So in respiratory, the parameter are in the different direction. That means when pH reduce, the rest of the two parameters increase. But first of all, partial pressure of carbon dioxide increase. Then what is the fate of respiratory alkalosis? In case of the respiratory alkalosis, when pH increase, first of all, first change occur in partial pressure of carbon dioxide, it will reduce, and bicarbonate level it also reduce. So in case of respiratory alkalosis, when pH increase, all the parameter decreases. So it is very important to remember that in metabolic cause, when pH reduce, rest of the parameter reduce. That means in metabolic acidosis, all parameter reduce. Metabolic alkalosis, all parameter increase. Respiratory acidosis, pH increase, pH decrease, but other parameter increase. And respiratory alkalosis, pH increase, but other parameter decrease. Now solve the equation. First of all, it is pH is 7.48. Normal range is 7.35 to 7.45. So it is more than 7.45. That means it is the alkalosis. It is alkalosis. But what type of alkalosis? For this condition we have to see other parameter. Here we can see the partial pressure of oxygen, which is 10.1. Bicarbonate, it is 30, and we know the normal range of bicarbonate is 22 to 28, so it is increase. So, and it is the alkalosis, and alkalosis bicarbonate level increase, that means this is the metabolic point. So when the bicarbonate level increase, that means it is the metabolic cause. And partial pressure of carbon dioxide 4.5, normal level of partial pressure of carbon dioxide is 4.5 to 6, so it is within the normal range, so there is no respiratory changes. Chloride is close to normal, and partial pressure of oxygen is also close to normal, so it is alkalosis due to bicarbonate, that means it is the metabolic cause. Bicarbonate represent the metabolic, so it is the metabolic alkalosis, which is the option C. So our answer, it is the metabolic alkalosis.